Hi there. Welcome to lesson 9.4 and 9.5. Today we're talking about linear, quadratic, and exponential models. We're going to compare all three models, okay? To review, a linear function has a constant first difference, okay? Constant first difference. As you can see, our x's are constant, 2, 4, 6, 8. Our y's, 5, 2, -1, -4. They have the same difference. They go down by -3. That's a constant first difference. That's linear. Next is quadratic. Quadratic functions have a constant second difference. My x's are constant. My y's going from -8 to -5 is +3. -5 to 0 is +5. 0 to 7 is +7. That's my first difference. Then from 3 to 5 goes +2. From 5 to 7, +2. This is the second difference. Okay, my second difference is the same, therefore it is quadratic. My third kind is exponential. Exponential have a constant ratio, which means the y's are multiplied. Okay, as you can see, my x's are constant and my y's, -2, -8, -32, -128, are all being multiplied by 4. If you are just given an XY table, that's how you tell between linear, quadratic, and exponential. Up here, which I neglected to look at, if you're given a set of ordered pairs, you are welcome to plot them. If I were to plot these ordered pairs, you would see that it makes a parabola, and we know parabola is quadratic. Okay, so let's move right along to these 5 problems. Okay, so what are they? Are they exponential, quadratic, or linear? Now, you are welcome to graph them if you want, or you can just look at it. All right, so I'm going to just look at them. -2, -1, 0, 1, 2. My x's are good. My y's, -4, -2, 0, 2, 4. Notice my y's are going up by 2, therefore it is linear. It has a constant first difference going up by 2. Next. And you have to excuse my nails are getting worse by the day. Next, -1, 0, 1, 2, 3. My x's are good. My y's, 4, 2, 1, 1/2, 1/4. Well, there you can see it's exponential. Okay, you could say dividing by 2, but dividing by 2 is the same thing as multiplying by 1/2. We always have to be talking about multiplying. Okay. Number 3, x's are good. My y is 6, 12, 24, 48. Exponential, multiplying by 2. Number 4, 0, 1, 2, 3 is good. My y's, 10, 18, 28, 40. Going up by 8, going up by 10, going up by 12. All right, so now let's look at the second difference. By 2, therefore it's quadratic. Notice, the second difference is the same. And finally, x's are good. My y's, 4, -2, -8, -14. Let's see. Not being multiplied. 4 to -2, going down 6, down 6, down 6. Therefore, that's linear. Common first difference. Okay? So that's our first part. Next page. Okay, again, talking about the difference between linear, quadratic, and exponential. Right here again. Okay? Linear, y equals mx plus b. Quadratic, standard form, ax squared plus bx plus c. And exponential, y equals ab dx. Okay, so now we're going to learn to write a function to model the data. Write a function to model the data. So here I have an XY table. Okay, we know that the year is X and the cost is Y. My X's are good, 0, 1, 2, 3. My cost, 80, 72, 64, 58, 32. Well, again, I need my calculator and I need to figure out what this is. Okay, so you got to determine whether it's linear, quadratic, or exponential. Well, it's not linear because there's not a common first difference. There's not a common second difference for quadratic, so therefore it's got to be exponential. Okay, so if it's exponential and here, okay, the reason why I know it's exponential is because I figure it out by putting 72 divided by 80. That's negative 0.8, okay? Well, here's the, this is actually showing that it's not a common first difference or second difference. Sorry, here it is. 72 over 0.80 is 0.9, excuse me. 64.8 divided by 72, 0.9. 58.32 divided by 64.80, 0.9. So I know it's exponential, all right? So exponential, what is the formula for exponential? Y equals AB to the X. By the way, see this 0.9? That is your B, okay? That's the constant ratio, okay? That is the constant ratio. So here's your formula. Y equals AB to the X. So I determined that from this table, it's exponential. Okay, and I figured out it's exponential because I did 72 over 80, 64.8 over 72, 58.32 over 64.80, I got 0.9. So that's my constant ratio. So I'm going to plug in 0.9 in for B. Okay, so now I'm missing an A, a Y, and an X. Well, I know what X and Y are. I can pick an ordered pair. I can pick this ordered pair right here. X is 0 and Y is 80. All right, so I'm going to plug in Y is 80. I don't know what A is, so I'm going to leave A here. And X is 0. Well, we know any number to the 0 power is 1. So A to the 1 is 80. So now I know what 80 is. 80. A is 80, excuse me. Here's my formula. Y equals AB to the X. They're asking you to write a model. If you look at the directions up here, write a function to model. So now I need an A and a B. I know B. B's right here. 0.9. I know an A. A is 80. So Y equals A, 80 times 0.9 to the X. And that is my final answer. Okay, we're going to try 2 more. All right, bear with me. Here we go. There are your 2. Okay, so we're going to decide if, first problem, determine the model that best fits the data. Okay, let's see. 1, 4, 16, 64. Well, right there, I can tell that this is, my y's are being multiplied, therefore it's exponential. So there's my model. Okay, formula for exponential, y equals a b to the x. There's my formula. Okay, well, what do we say b was? We looked up there, we know that b is the constant ratio. So what's going on here? Isn't it being multiplied by 4? So b is 4. Times 4, times 4, times 4, b is 4. So I'm going to take b and put it right here. Okay, fantastic. But now I'm missing an x and a y. Well, here's my x and here's my y. I'm going to plug that in. Y is 1. Don't know what a is. We'll leave a there. And x is 0. Any number to the 0 power is 1. So A equals 1. All right, I got an A, I got a B, I'm good. Y equals A 1 times B 4 to the X. And I'm good. Okay, let's try the next one. Let's see if this is exponential. All right, 7, 10, 13, and 16. That does not look exponential to me. That is not being multiplied, but it looks like there's a common first difference. Common first difference means linear. Okay, so therefore it's linear. If we look up at the top, linear means y equals mx plus b. All right, well, we can figure out, what's the first thing we need to figure out? The slope. How do we figure out the slope? Y2 minus y1 over x2 minus x1. I'm sure we'll remember that. Y2, 10 minus y1, 7 over x2 minus x1, which gives me 3. Okay, our slope is 3. Great. What am I missing? X and y and b. Well, we can do it a couple ways. I see a y-intercept. Your y-intercept is 0, 7, isn't it? Is my y-intercept 7? Well, I got a slope. I got a y-intercept. I can write the equation of the line. Y equals 3x plus 7. Alrighty. That's our second page. And the last page. Okay, our last page has to do with comparing functions as well. Our last page has to do with comparing functions as well. Okay, again, we're talking about linear, quadratic, and exponential. Okay? A linear equation, y equals mx plus b, quadratic, ax squared plus bx plus c, and exponential, y equals ab to the x. Okay? The rate of change. The rate of change in a linear equation is constant, but the rate of change in quadratic and exponential is variable. Okay? And you can compare them. We're going to do that now. You can compare functions in different representations, including tables, graphs, or equations. All right, we're going to compare them by finding slopes and y-intercepts. So let's compare Evie with Lucy. We're going to compare Evie to Lucy's college fund. All right, so looking here. Hold on, let me make sure you guys can see this. Okay, so looking here, we have Evie's every month, Evie's balance, okay, we can see is going up by $100. Okay, Lucy, Evie's starting with 1,000, going up by 100. Lucy's starting with 1,200. Okay, and what's she going up by? Well, we need to find the slope. So we found the slope for Evie. We'll talk about Evie first. Okay, y2 minus y1 over x2 minus x1. We found her slope to be 100. Evie's slope is 100. And then Lucy's slope, we picked two ordered pairs. They did 0, 1,200, and 5, 1,600. So they used the big numbers. Okay? And they found her slope to be 80. y2 minus y1 over x2 minus x1. All right, and you could see the y-intercept is 1,000, and Evie's Lucy's y-intercept, is 1,200. Okay. So what could we say here? The slope is the rate of change. Evie's saving at a higher rate. She's saving $100 a month, whereas Lucy is only saving $80 a month, even though Lucy started with more money. Okay, so let's try this example. John and Jeremy. All right, let's talk about John and Jeremy. John and Jeremy save money weekly from their allowances is shown. Compare the accounts by finding and interpreting slopes and y-intercepts. So we're going to interpret slopes and y-intercepts. So let's do the slope of each. Let's do John's slope. We got John and we have Jeremy. All right, so let's do John's slope. John's slope, y2 minus y1 over x2 minus x1. So 16 minus 11 over 1 minus 0. So John's slope is 5. Okay, and Jeremy's slope, gotta make this a little. And Jeremy's slope is, let's see, let's use two ordered pairs, 0, 4. And you can use a lot. You can use, I'll use here. Okay, you can use any of these ordered pairs as long as they hit it in the corner. So, Jeremy's will use 8 minus 4 over 1 minus 0. I'm using the ordered pairs 0, 4 and 1, 8 for Jeremy. So Jeremy's is 4. Can you see that? Yes. Okay? So, interpret. Who's saving more money? Is John saving more money or is Jeremy saving more money? Obviously, John is saving more money. Okay, y-intercepts. Well, John's y-intercept is 11. Jeremy's y-intercept is 4. So, John is 11. Jeremy is 4. So who's starting with more money? Clearly, John is. Okay, and there we go. Okay, you guys have a MyHRW assignment due starts Monday morning and due Wednesday night. I have office hours every day, Monday through Friday from 10 to 11:30 a.m. Please let me know if you have any questions.